Imagine walking into a software company in 1975 and telling a room full of assembly programmers, in 50 years, millions of people who have never studied computer science will build software simply by describing what they want in English. They probably wouldn't have believed you. Not because the computer couldn't do it, because they couldn't imagine another rung on the ladder. Today we're watching that rung appear in real time. The history of software isn't really the history of programming languages. It's the history of abstraction. And every time we've climbed another level of abstraction, we've dramatically expanded who could create software and what they could build. Large language models aren't breaking that pattern, they're continuing it. Let's start with a deceptively simple question. What exactly is abstraction? People usually say abstraction is hiding complexity. That's true, but I think there's a better definition. Abstraction is the process of replacing implementation with intent. Think about driving a car. When you press the accelerator, you aren't thinking about spark plugs, fuel injectors, crankshafts, or combustion chemistry. You're expressing an intention. Go faster. Everything underneath translate that intention into thousands of mechanical operations. The complexity hasn't disappeared. It's simply been placed behind an interface. Software works exactly the same way. When a programmer calls a function named sort, they aren't instructing the process to compare memory locations one by one. Someone else already solved that problem. They simply say, sort this list. That's what abstraction does. It allows humans to think less about how something happens and more about what they want to happen. Once you start looking at software through this lens, the entire history of computing becomes obvious. Each generation stands on top of the previous one. Machine code came first. Programmers literally told processors which electrical operations to perform. Then came assembly language. Instead of writing numerical instructions, programmers wrote symbolic ones. Then came compiled languages, like Fortran and C. One line of source code could become dozens or hundreds of machine instructions. Then operating systems abstracted away the hardware. Libraries abstracted away common algorithms. Frameworks abstracted away application architecture. Python abstracted away much of the boilerplate that earlier programmers had to write by hand. Each step followed exactly the same pattern. The computer became more complicated. The programmer's job became simpler. Or perhaps more accurately, the programmer could spend more time thinking about the actual problem. For a long time, Python felt like the final boss of abstraction. Its syntax was so readable that people joked it was basically English. But it wasn't. Python is still a programming language. Every colon matters, every indentation matters, every keyword has to be exactly correct. The computer still demands that humans translate their intentions into its language. Large language models reverse that relationship. Now we describe our intentions in our language. The model translates them into code. That's an entirely different level of abstraction. Instead of saying, create this class, import these libraries, instantiate these objects, we simply say, build me an application that does X. The machine figures out the implementation. This brings us to the concept I think matters most, agency. Every rung on the abstraction ladder increases human agency. A machine code programmer had incredible control over the processor. They could accomplish relatively little in a day. Today's software engineer can build products that would have required hundreds of programmers 50 years ago. The programmer isn't necessarily smarter. They're standing on generations of accumulated abstraction. That's why economic value tends to move upward. We still need chip designers. We still need compiler engineers. We still need people writing operating systems. Those jobs aren't disappearing. But most businesses don't create value by optimizing processor registers. They create value by solving customer problems. The closer your tools allow you to work to the customer's problem, the more leverage you tend to have. LLM coding agents push that frontier upward once more. Instead of spending hours writing syntax, developers increasingly spend their time defining objectives, reviewing solutions, and making architectural decisions. The scarce resource shifts, less syntax, more judgment. There's a temptation to think this is completely unprecedented. I don't think it is. Researchers Arvind Narayanan and Sayesh Kapoor describe AI as a normal technology. I think that's exactly right. Electricity was a normal technology. The internet was a normal technology. Businesses slowly reorganized themselves around new capabilities. That's exactly what's happening with AI coding. Models improve, companies gradually redesign workflows, engineers adapt, organizations change. This isn't magic, it's technological diffusion, which means history is probably a better guide than science fiction. That leads to the most interesting question. If natural language is today's abstraction, what comes next? I don't think we'll stop at telling software what to build. I think we'll eventually tell software what outcomes we want. Instead of saying, build a claims processing application, you'll say, reduce claims processing time by 30% without increasing fraud or exceeding this budget. The system will decide whether software is even the answer. Maybe it changes workflows or interviews employees or automates paperwork. Maybe it builds software. Maybe it does all four. We would no longer be specifying software. We would be specifying reality. That's an entirely different level of abstraction. The history of software has always been about increasing the distance between what humans must say and what computers can do. Machine code required us to think like processors. Assembly let us think like programmers. High-level languages let us think like engineers. LLMs let us think like users. The next abstraction may let us think like executives or policymakers. The lower layers won't disappear. They never have. Someone will always need to understand what's happening under the hood. But the greatest opportunities will continue moving upward, or at the highest level where humans can exercise agency. That's why I don't think LLM coding agents are the end of programming. They're simply the next rung on a ladder we've been climbing for the last 70 years. And if history is any guide, there's still many more rungs above us.